right, let's do another video. So pause me to copy this down. First though, I want you to, I've got a little messy here. This is tangent A plus tangent B on top. This is one of the times where the T kind of gets messed up with the plus sign. So tangent A plus tangent B, you can look this up in your book if you want to see it in type instead of written, because it's easier to see that way. And then 1 minus tangent A, tangent B. These are being multiplied together on bottom. So pause me for a second and write all this stuff down. Okay. And, all right. So I have a little silly song for you guys. Get to hear me sing today. We're going to focus on this one and this one. Okay. So just a little trick to help you hopefully memorize these formulas. If it doesn't help you, come up with your own way to memorize them, okay? All right, so sine, cosine, cosine, sine, cosine, cosine, sine, sine. Yep, I'm okay with making a fool of myself on YouTube. Totally fine with that. All right, and you're probably like, what the heck just happened? That's okay too, because that's normal for this song. If you pay attention here, as I'm, I don't even know if it's more of like a chant or a cheer or something, right? Not necessarily a song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right. Extra credit if you can figure out why I clapped. I'm just kidding. You don't get extra credit. So let me look at this. You've got a plus matching a plus here, and you've got a minus that's opposite the plus there. So that's what the clap is for, okay? And then it's just, it's a little easy thing to memorize. Sine, cosine, cosine, sine, cosine, cosine. Somebody clap for me. Sine, sine. Right? Okay. So I said it 3 times. Usually when we're in class together, I make you guys sing it. And if I don't see people singing it along, then I make them go to the board and do it by themselves. So count yourselves lucky. You'll notice that these two have the same pattern. The sine, cosine, cosine, sine. The minus matches the minus, just like the plus matches the plus. These two have the same pattern, cosine, cosine, sine, sine. The opposite for the clap and the opposite for the clap, okay? And then I'll show you how I use that in a minute. I don't have a song for the tangents. I made the mistake of asking at some point a very, very long time ago for somebody to come up with a tangent song, and they did it to the beat of a Justin Bieber, and I regret that decision for the rest of my life. Okay, so these are formulas we're going to use. You need to memorize them. Here's how we're going to use them. Use sum or difference formulas to find the exact value. So if you didn't already write that down, pause me to write that down. My first suggestion is going to be converting to degrees, because generally we just think better in degrees. So hopefully you remember how to convert to degrees. Take a second and think about that. It's been a long time with that like 2.5 week break that we had. All right, so to convert from radians to degrees, we use pi over 180 or 180 over pi. Hopefully you remember that, and hopefully you can remember which one we're going to use in this situation. Take a second. So we want the pi to be gone, right? So we're going to do that. So I'm going to try and think about how many times does 12 go into 180, because I want my numbers to get easier, smaller, before they get larger. So 12 goes into 18 one time with what, 6 left over, so 60. And 12 goes into 65 times. So this is 15. Can you do that with a calculator? Sure. Am I going to let you have a calculator on a test? I honestly don't know, because I don't have any idea how tests are going to work. So 13 times 15 is 195. So what this question is actually asking us to find is sine of 195. We don't know how to do that without a calculator. That's not a value in the unit circle. So remember, the unit circle has all of the 30s and 60s and 45s. Let me draw it up here. If I were to draw 195, I would be 180 plus 15. That's not a reference angle that we're used to seeing in the unit circle. So we can't do this without the formulas that we have on this paper. So what I need to think about is, can I turn this 195 into a sum or difference of two angles that I do know in the unit circle? So hopefully right off the bat, you're thinking, oh, sine of 195, that ends in a 5, so it must be a 45. Sine of 45 plus what makes 195? 150. So I haven't changed the value. I've just split the 195 up into two different angles. And hopefully you remember that 150 is one of the angles that we can find sines and cosines of. So we're not going to need a picture for 45. Some of you won't need a picture for 150, but I'm going to draw it anyways. So 150 is 30 degrees short of 180. That's how I know we can do it. The reference angle is 30. We can do problems that have reference angles of 30s, 60s, and 45s. So I'm going to apply the formula. Sine, cosine, cosine, sine. Okay. Another little trick. The part of the song that starts with, like, you kind of have to remember that there's like 4 things we're saying for each. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine, right? So the cosine, cosine part, it goes with the cosine, and the sine, cosine part goes with the sine. So hopefully that makes it a little easier to remember. So here's what I'm going to do. I'm going to sing this song in my head. Sine, cosine, cosine, sine. I did not clap, so the plus matches the plus from there, okay? And then from there, you'll see it just goes A, B, A, B. A, B, 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 A, B. So I'm going to go A is 45 in this problem. And B is 150 in this problem. And then it's easy, hopefully. Dusting, again, dusting the cobwebs off. It might take a second, and that's okay. Don't get frustrated with yourself. It's been a while since we've done these. But hopefully, I want you to pause me and see if you can remember these values here. So I'm going to, hopefully you paused me and tried. I'm going to give you an idea of what I'm talking about. Sine of 45. I hope that we all can do that without a picture. 45 is in the first quadrant, right? We know these are rad 2 over 2, rad 2 over 2. Sine is the y over the r, and we're in the unit circle, so r is equal to 1. So sine of 45 is rad 2 over 2, okay? So that's what I was talking about. If you were a little bit stuck on that, pause me again and see if you can find the rest of these trig values. Okay. Cosine of 150. So we have a picture for that here. We need to remember that across from 30 is a 1/2. And then this would be a 60-degree angle. I don't want to try and squeeze it in there. Sorry, my kids are home, so you get to hear them playing in the background. Across from 60 is a rad 3 over 2. This is positive because it's up. This is negative because it's left. The cosine is the x over r. So this is going to be negative rad 3 over 2. Cosine of 45, we already talked about that. Those are both rad 2 over 2 in the first quadrant, so they're both positive. And then sine is the y over r, so 1/2. And when I multiply these together, radical times a radical, I can multiply. And then I can write this, oopsie, sorry. I can write this as one big fraction because they have a common denominator. That's a negative right there, you guys. Okay. All right. So hopefully we're good there. Tangent of 15. Let's move on. Sorry, pause me if you need that for another second. All right. Tangent of 15. How can I get 15? I need to think 45s, 60s, and 30 reference angles. Okay? So take a second and see. We can either add or subtract to get 15. Okay, so 45 minus 30. Some of you might have done 60 minus 45. Some of you might have done 135 minus 120. There's an infinite number of ways to get these. I always go with the smallest numbers. And then now I'm going to apply the formula. I'm just going to look directly here. So this is A and this is B. I'm going to go tangent of A minus tangent of B all over 1 minus, oopsie, plus tangent A times tangent B. Okay? Again, the 45, we know that one, right? Rad 2 over 2 for both of the sides, x and y. Remember, tangent is y over x. So if I have rad 2 over 2 divided by rad 2 over 2, that's just going to be 1. Okay, let's draw the 30, though, because that's a little bit harder. 30 across from 30 is 1/2. We know that reference angle is 60, so this is rad 3 over 2. They're both positive because it's in the first quadrant. I need to think about y over x, right? Y is 1/2 over x is rad 3 over 2. And hopefully you remember what this goes to, but again, it's been a little while. So I can multiply by 2 over 2 or multiply by the reciprocal, however you want to think of it. And then when I rationalize the denominator, I get rad 3 over 3. I'm not going to show you rationalizing the denominator. I know you guys can do that. And then I have 1 plus on bottom. Tangent of 45 was 1. Tangent of 30 we found was 3, right? And then now we need to go back to a previous chapter. We're not allowed to have fractions within fractions, so we need to know how to get rid of it. I want to get rid of 3 in the bottom, so I'm going to multiply by 3. I'm going to do it on top and bottom because that's what I have to do when I'm looking at expressions, not equations. And I'm going to distribute. So I have 3 minus, what's going to happen here? When I multiply these together, that's going to cancel. So I'm just left with rad 3 over 3 again and rad 3 again. This time with a plus in between. 3 plus, sorry, I'm distracted by my kids making noise. I want to make sure this is right. I think it is. Okay. And then just like we've always known our whole lives, or at least since we were in pre-algebra probably, we can't have a radical in the bottom. So hopefully you remember multiplying by the conjugate.